All right, welcome back to The Explainer. Today we're doing something a little different. We're stepping into the cosmic kitchen. Yeah, you heard that right. Our main ingredient, raw asteroid material. We're talking a messy jumble of rock, metal, and ice. And our mission is to turn all that stuff into the fuel and the building blocks for our future right there in space.
So here's the deal. The problem is pretty straightforward. Space is just this chaotic, messy pantry full of raw asteroids. And look, shipping that entire mess back to Earth, not an option. It's just too expensive, too inefficient. So the real mission here is to sort it, separate it, and transform all those raw ingredients right where we find them. It's time to put on our cosmic chef hats. Okay, so here's the game plan for today. Our recipe, if you will. We're going to cover why we'd even cook in space in the first place. Then we'll get into prepping and sorting the ingredients, the actual cooking process with sunlight and chemicals, and finally, plating up, which is all about in-space manufacturing. Let's dive in.
All right, first up, welcome to the cosmic kitchen. This is where the magic really happens. We're talking about taking that jumbled mess of space rock and piece by piece turning it into pure, super valuable materials. This is the crucial step between just, digging stuff up and actually using it.
But you might be wondering, why go through all this trouble millions of miles from home, right? Why not just haul the rocks back to Earth? Well, that gets us to what we're calling the smart chef's logic. Think about it this way. If you're out camping, you don't chop down a tree and then drag the whole log back to your car, right? No way. You process it right there at the campsite. You cut the firewood you need. Space logic is exactly the same. Shipping tons of useless rock and dirt back to Earth would burn an absolutely insane amount of fuel. So by processing on-site, and the fancy term for this is in situ resource utilization, or ISRU, we get to send back only the good stuff. We leave all the waste behind. It's all about efficiency.
Of course, our cosmic kitchen has one huge, unique challenge: zero gravity. On Earth, if you make a mess, dust settles. In space, nope. Everything just floats. It's like a cloud of confetti that never lands, and that is a massive hazard for both people and equipment. So what's the solution? Containment. You have to do everything inside sealed bags, enclosed domes, and automated machines just to manage the chaos.
Okay, so how do we actually do all this? Let's break down the recipe. We've got a kind of 4-course menu to get through.
Here's the roadmap, our whole process in a nutshell. First, prep. We crush and grind the raw asteroid chunks. Then, sort. We separate the good stuff from the junk. After that, cook. We use heat and chemicals to extract exactly what we need. And finally, plate. We actually manufacture it into something useful. So let's take a closer look at each step. First up, the prep work. The technical term is beneficiation. But let's just stick to the smoothie analogy. It's perfect. You can't just toss a whole apple into a blender and expect a smoothie, right? You've got to chop it up into smaller, manageable pieces first. And in the real world of our cosmic kitchen, that means using robotic crushers and spinning drums. Honestly, they kind of look like giant industrial-strength food processors. Their job is to smash the asteroid material down into gravel or even a fine powder. And this is key. It all happens inside contained bags to prevent that zero-G confetti mess we talked about. Okay, so once everything's crushed down, we're on to step 2, sorting. And our first tool for this is the good old magnet trick. Imagine you spill a box of pins on a big, shaggy carpet. What's the easiest way to pick them all up? You grab a magnet, of course. Well, in space, it's pretty much the same principle, just on a bigger scale. The crushed-up material moves along a conveyor belt, and powerful electromagnets just pluck out the magnetic metals like iron and nickel. And since those are super common in M-type asteroids, it's a really simple, low-energy way to separate a huge chunk of the valuable stuff right off the bat. But wait, not everything is magnetic, right? So what's our next trick? Well, it's static electricity. I mean, we've all been there. You're sorting laundry and you've got that one sock that just will not let go of a shirt. That's static cling. So we can basically weaponize that static cling for our sorting. We give the crushed powder an electric charge, and different types of materials will hold different charges. Then, as they pass by these oppositely charged plates, they literally just stick to them. It's a method that works incredibly well in this super dry vacuum of space, where static is easy to generate.
All right, our ingredients are prepped and sorted. It's time for the main event, the cooking. This is where we get to use some serious heat and chemistry to really pull out the good stuff.
Let's stick with our kitchen theme. Think about baking cookies. You put the dough in the oven, and the heat does two things, right? It turns the dough into a solid cookie, but it also releases gases, that amazing smell. Well, in our cosmic kitchen, those released smells, those gases, are often incredibly valuable resources, like water vapor.
The reality of this is a process called pyrometallurgy, and it's pretty awesome. We're talking about massive arrays of mirrors that focus sunlight into one incredibly intense beam. It's basically the world's most powerful magnifying glass. This thing can heat a crucible to over 3,000 degrees Fahrenheit. That's hot enough to melt metals, so we can pour them into bars. And any of those volatiles, like water, they just evaporate off and get captured.
And speaking of volatiles, the absolute grand prize here is water ice. Finding water is hitting the jackpot. Because once we melt it, we can use a process called electrolysis to split it into its parts. Think of it like a battery running in reverse. Instead of getting power from chemistry, we zap the water to create a chemical reaction, and that splits it into hydrogen for rocket fuel and oxygen for breathable air. I mean, this is a total game changer for living and working in space. But hey, heat isn't our only cooking method. We can also use chemicals to extract what we want. The best analogy here? Just making a cup of tea. The hot water acts as a solvent, right? It pulls all the flavor out of the tea leaves, and you're left with the good stuff to drink and soggy leaves to throw away. So in the real world, this is called hydrometallurgy, or chemical leaching. We mix the crushed ore with a solvent that's designed to dissolve only the metals we're targeting. But the really cool innovation here is the move towards green chemistry. We're talking about developing eco-friendly solvents that can do this job without needing harsh acids or, get this, even using up our precious supply of water. Okay, our ingredients are cooked, they're purified, we're at the final step in our cosmic kitchen, plating up. This is all about turning those raw materials into actual finished products. The analogy here is pretty fun. Think Legos or chocolate molds. On one hand, you can take the refined, molten metals and pour them into molds to create simple things, like bars or support trusses. But even better, you can use that metal as the ink for giant 3D printers. Imagine printing complex tools, replacement parts, or even sections of a habitat all on site. This is how you start to build a real, self-sustaining economy in space. So, when you take a step back and look at the whole process, it's way more than just a series of industrial steps. It's almost like a form of alchemy. We're literally transforming a messy pantry of useless rock into the very foundation for a new frontier. And this represents a really fundamental shift in how we think about space. Just digging up material, that's like using a field guide. You're just identifying and collecting things, managing a mess. But processing, everything we've talked about today, that's like using a cookbook. It's about control, it's about transformation. It's about optimizing a recipe to get exactly what you want. We've basically gone from being cosmic hunter-gatherers to becoming cosmic chefs. Because ultimately, that's what this is. Processing is the alchemy of space. It gives us efficiency, because we can leave all the useless stuff behind. It gives us adaptation, forcing us to invent clever ways to work without gravity, using things like magnets and static. And most importantly, it gives us transformation. It's how we turn what is essentially worthless rock into breathable air, drinkable water, rocket fuel, into the very structures that will define our future in space. So this whole process, it's the recipe. It gives us the ingredients we need to build a real, permanent human presence beyond Earth. And that leaves us with one final big question to chew on. Now that we have the cookbook, now that we know how to cook in space, what will be the very first thing humanity actually builds out there on the high frontier?